Hello, friends. Welcome to the ATC Double Cut. We have a special turf math episode again today. Bjarni Hannesson is joining me all the way from Iceland at the, is it G Moss Golf Club now?
GMOS. Well, that's the international version. If you're domestic, it's Golfklubber Mosfellsbæjar, but GMOS does it.
All right. Well, that is, I'll just stick with G Moss.
Yep.
I can say that. So you're, September, we're recording this. So you're coming to the cooler times of the year.
Yes,
Day
very
lengths,
much so.
day lengths are still okay though. You're coming up on a 12-hour day.
Yeah, but it's sun is coming up around 6:30 right now, so we've shifted start times. We don't have as much pressure on us, so we're starting to show up at 7 by now.
Nice. Well, thank you for being able to join me for the Turf Math. I guess this is episode 3 of Turf Math.
That's it.
The sub series here on the ATC Double Cut. So you had a very interesting topic that I thought was great, and I said, "Hey, well, let's record that as soon as we can." And you said that one of the common questions you get is, "Tell me."
Because sometimes I've been asked, I've done talks on MLSN before, and it's soil testing. And on your soil testing reports, we usually get the results and ppm or mg/kg. And if you're not, I'm assuming if you're not metrics, you might not know that that's milligrams per kilograms, but I don't know. You might not know that. But ppm being parts per million, and the question is that I always get, what does it mean? How can I, because we don't use, when we're talking fertilizers, generally among greenkeepers, we don't throw out, I'm putting that many milligrams per kilograms of fertilizer. It's not a common thing to talk about. So it's understandable that people, when they haven't sat down and thought about it, it's like, what does the ppm mean exactly? And how much material is out there that we just measured? What does that mean, ppm? And why ppm and milligrams per kilogram? Why is that the same?
Well,
So
let's talk about this, because when you said that, I thought, yeah, that's a great point. I think we should try to explain it, and I imagine it might actually be interesting to hear, because it's not something that we've had a long conversation about, like what it really means. And I suppose when we talk about it, some people will at least hear how we think about this, and we will try to explain how it's related to things like fertilizer rates and to nutrient harvest and to whether you need to apply fertilizer or not, or that kind of thing. Now, I'm going to show a blog post real quick. I'm showing now a screenshot of the blog post that we'll supposedly give the double cut treatment here, which is titled New MLSN Cheat Sheet. And all I'm going to say is I'm going to put a direct link to this in the show notes. If you want to find out all about MLSN and find a whole lot of ppm numbers or milligram per kilogram numbers, you can find it on this MLSN cheat sheet. And it explains all about MLSN. But if you're not comfortable with parts per million or milligrams per kilogram, and if those numbers and the units of those numbers, it's not in pounds per 1,000 square feet, it's not in kilograms per hectare. If those numbers are not intuitive and making sense to you, then this entire cheat sheet is not going to be of very much value. So I'm not going to talk about the cheat sheet anymore. We're going to go back to the start and try to figure out what we mean and how we can make good use of milligram per kilogram or translate that into something that's
something, a unit that we often talk about, when we're applying fertilizer, because we usually have, an area a weight by an area that we're applying fertilizer to. So we talk about kilograms per hectare, pounds per thousand, grams per square meter in that sense. So we need to sort of translate it into that so we understand what we're talking about, really. But the good thing about ppm for the imperial guys is that it's effectively unitless. It just means 1 part per million parts of
Right.
whatever parts you have, right?
Right. So it's unitless.
In that sense, oh, sorry, yeah, it's not a metric. It's a not non-specific metric, or not. It's not specifically metric, not specifically for the imperial guys, because you could technically speaking use it on both sides, because it's just 1 part of a million, effectively.
Effectively.
Now,
But
yeah,
but the part where it comes to soil is
mhm,
slightly tricky because it could be 1 milligram per liter,
mhm,
or it could be 1 milligram per kilogram. Now,
yeah,
I'm most comfortable with it expressed on a weight basis, which is the way it's typically done in the United States. But
yeah,
sometimes in the UK, the soil tests are reporting on volume of soil rather than on mass of
um,
soil. So
yeah,
that for me is a little bit, I don't like it because I'm not quite
yeah,
sure if their leader, how much it weighs. so,
yeah, because
so, so
it can
that,
shift a little bit.
yeah, it can
Yeah.
shift a little bit.
Mhm.
But yeah, basically what we're talking about is a tiny part in a larger part. And so if
Yeah.
you have, how much is 1%? If you have,
It's 1/100th. So this is yeah, out of 100%. Well, it would be 1 part per million would be 0.01%, roughly like that, right?
1 part per million, you need a
No, you need 6.
thousand. Yeah, this is
Put me on the
where
spot here.
this is where
On the
we
percenting was.
no,
I think
you
a
need
good
more than
way.
1,000. 1,000 would
Yeah,
be 1/1000th. You
yeah,
need
exactly. It's
you
one
need
one
ten
million.
thousand.
Yeah,
Ten
yeah,
thousand.
10,000 and then 2 zeros. Yes, you're correct.
So so it's
10.
so it so the reason why the units are in parts per million is because the nutrients in the soil tend to be at relatively low concentrations. And so when they're checking how much potassium you have in the soil
Mhm.
compared to everything else that's in the soil, it tends to be something that expresses well on a parts per million basis, because you
Yeah.
might have like 150 parts per million.
Mhm.
But for that to be 1%, it would need to be 10,000 parts per
Mhm.
million
Yeah.
if I've done the math in my head
Yeah,
correctly.
you're right.
Because 100,000 out of a million would be 10%. So
Mhm.
1% should be 10,000.
Yeah.
And for anybody who's done Malic 3 soil tests, you may have seen in a calcareous soil, you may have seen that a calcium, sometimes you'll get a calcium number that's 10,000 or 15,000 parts per million. You can
Mhm.
get that when it's calcareous and the Malic 3 extractant dissolves some of the calcium carbonate that's in the soil. And that is like an extremely high number. It's like off scale high to be 10,000 or 15,000, because normally the calcium in soils will be 300, 700, 2,000, 5,000, something like that. But even 5,000 is just half of a percent.
Mhm.
And and so that's one way to think of these numbers.
Yeah. But I think it's okay if we explain to him a little bit about if you're an imperial guy and you're wondering what does milligrams per kilogram actually mean, and why is it equivalent to ppm part per million. If people are not used to the prefixes that are used in the metric system, for example, the prefix of milli, milli just means 1/1000th of the base unit, and in the metric system, the grams are the base units for weight, and gram is a relatively low weight. I mean, what is that in
Right.
ounce
So
is what?
so one pound. So everybody that's familiar with pounds, 1 pound is 454 grams.
Mm,
So basically, you have 1 divided by 454 pounds. That's how
mhm.
much a gram is. I don't
Yeah,
know how much that is in ounces, but I know
28 grams an ounce. Is that possible? Well, anyway,
it's
I don't have
quite
the
possible.
calculation.
I just know how
Yeah,
to make the relationship
yeah,
um,
the pound.
to the pound. So
Yeah,
a gram is 1/454th of a pound. It's a very small unit. And if
yeah.
you think about that in terms of fertilizer grains or sand
Mhm.
grains, it's basically a couple grains of sand.
Yeah.
Um, be,
It's a very low measuring unit, and therefore we use prefixes sort of to describe. And the prefixes just means what how I mean and how often it's been. What do you call it? The power of it, or the multiplier of the base unit. So a kilogram that you often hear, kilo just means 1,000 times the base unit. So kilogram would be 1,000 grams.
mhm,
Milli is the opposite end of that. That's the 1,000th of the base unit. So you divide the base unit, the gram, by 1,000, and then you get a milligram, which is a tiny fraction. It's a very light. It's tiny. But those of you who are good in math, and those you might have noticed that you're having a milligram, which is 1/1000th of something. So we got 3 zeros there, and then you've got kilo, which is 1,000 times the base unit.
mhm,
So you got 3 zeros. So that means you will end up, if you put this into your calculator, you'll get one millionth. So one
mhm.
millionth part of the sample, which is the same as part per million. That's why ppm and milligrams per kilogram come out. It means it can mean the same, as in that's why you can transfer from ppm to milligrams per kilograms, roughly,
Right.
sort of.
And that's
If it's based on weights, the ppm is based on weights.
if it's based on weights. And
Yeah,
that's quite it's quite simple. Now you could have, I mean, I guess you could have a part per million and it could be in pounds, but there's no
yeah.
particular unit that is one
Hmm.
millionth of a pound.
No,
But it's very simple with the way that the metric system prefixes go.
yeah.
You know that to go one millionth of a kilogram will be 1 milligram because
Hmm.
you go back 3 zeros to get to the base unit of gram, and then you
Hmm.
go back another 3 zeros to get to the milligram, and there you have it. So it's a
Uh,
10 to the 6th difference.
yeah, and this might be obvious to the metric guys, but I'm assuming if you're an impeller guy, why would you know this? Why would you know all these
Well,
prefixes?
I think we
Well,
learn it. I think in the United States we learn this
yeah,
because
but maybe,
we're all taught the metric system in, I don't know, 3rd grade, 4th grade, whatever. But
yeah.
then in our daily lives, we tend not to
Hmm.
use it. And
Hmm.
you know, now I've lived outside of the United States now for 17 years or so. Consecutively. And prior to that I lived outside the US for a couple of years also before going to graduate school.
Yeah.
And so when I go to the US, here's an interesting, or to me it's something that I found that I now think in the metric system. When I use Google Maps and I'm driving somewhere in the United States, and I had my phone Google Maps audio set to be using the uh, using the units of the place where I am. And
Yeah.
so it'll say, all right, turn left in a quarter mile. And I'm just like, oh, I forgot how far a quarter mile is. And then it's like, okay, turn left in 600 feet or turn left in
Yeah.
200 feet. And I'm like, can this please be in? So I go through all the settings in Google Maps. And finally, I got it set to be like, okay, always use meters and
Yeah.
kilometers. So now I know, okay, turn left in 500 meters, and I'm very comfortable with being able to do that.
Yeah, I just stick to metrics. But
Yeah.
well, saying that, I've spent good enough time, so I got some base units good in my head, but constantly forgetting,
Yeah. So,
how fluid ounces and all that stuff. I'm lost with that, to be
but
fair.
so I know that if you're listening to this from a part of the world where you use pounds and ounces
Hmm.
and acres and thousand square feet and so on, I know that
Hmm.
you'll have been introduced to this
Somewhat to
concept
it.
of the metric and how things are in
Yeah.
multiples of 10 or multiples of 1,000.
Hmm.
But if you don't use it all the time, you forget and you lose
Yeah.
the fluency of being able to make those changes. So anyway,
But yeah, so now at least we know this, the milligram per kilogram, what it means. But how we're going to use it? That's really the question I always get. Like, how does that relate to what we're looking at in the soil?
and well, that's
Now,
you can maybe that's when you can go look at the MLSN cheat sheet or look at
yeah.
some of the explanations that I've made. I've got various videos where I've explained it, various presentation slides that are available for download where I've tried to explain MLSN or
Hmm.
various blog posts. So I'm thinking of this in terms of fertilizer for now. So let's use potassium, which is quite an important element because if you don't have enough potassium, that would be problematic. So we want to apply fertilizer, but we don't apply fertilizer in ppms. But we want to make
Yeah.
sure that the soil has enough potassium. So
Hmm.
that's where I'm I think this is a really good thing to try to explain because it's something that you and I at once we had to wrap our head around what's going on too. It's like you don't just know this at first to how
No,
to make these conversions.
no.
So what do we
We
do?
so by the way, I tend to, when I'm looking at fertilizer, I just tend to use. I know you're in the gram per square meter category, but I think it might be better to explain this in kilograms per hectare because the numbers just work out slightly easier that way.
Okay,
Then they end up
let's do
very
it
similar.
let's do it that way. And I apologize to my two listeners in Japan who would rather it be in grams per square meter.
We can do it in grams per square meter later on, but
Yeah.
I'll explain this now. So hectare, for those that don't know what a hectare is, it comes from the prefix hectometer. Hectometer just means a hecto just means 100 times the base unit. So hectometer would be 100 meters, and hectare is then the square area of that. So 100 meters times 100 meters, that's 10,000 square meters, and that's 1 hectare. The reason for I tend to like it is just because often greens on 18-hole golf courses are close to being 1 hectare. So it's a very sort of tangible number if you speak about like how many kilograms did you apply to your greens, because you actually physically hold the kilograms, you put it into your sprayer, and that's why I tend to like the hectare as a base unit. I fully understand the square meter concept. Don't get me wrong, and apologies to the Japanese out there. So, but okay, hectometer is 10,000 square meters, so we know that. Now, if we did use your cheat sheet, you probably recommended in the cheat sheet that we would go 10 centimeters down, which is pretty much 4 inches to the depth.
Mm-hmm.
So if you do use that, that just simplifies calculations quite nicely, because now we're going to try to figure out how much does that soil weigh that we took samples out of. Now, if that soil to calculate the weight of the soil in this area, now we need to have a three-dimensional unit, and the three-dimensional unit will be the hectare, so 100 times 100 meters, so 10,000 square meters, times the depth. Now the depth is not 1 meter; it's 0.1 meter. That's what 10 centimeters means. So if you multiply the 10,000 square meters by 0.1, we get what, 1,000, right?
Mm-hmm. So that's 1,000. Is that 1,000
Cubic
cubic meters?
1,000 cubic meters. of soil. Um, it's kind of hard to wrap your head around 1,000 cubic meters, right?
Well, that's 100 trucks that each have 10 cubic.
Yeah.
It's 10 times 100, right? So
Yeah.
that's 100 trucks that each have 10 tons of,
Material in it.
yeah,
Yeah.
or
Yeah.
10 cubic meters
10
of
cubic meters of,
yeah.
yeah. So, um, so if we have then, we know that. But the thing is, soil. Now, if this was water, and we get back to the water being at what 20 degrees at 1 bar of pressure, then we know that the cubic meter weighs 1,000 kilograms or 1 ton. That's the weight of it. So effectively, if this was water, we would have then million kilograms, right? Thousand
Well,
cubes, right?
yes.
1,000 cubes, and each one of them weighs 1,000 kilograms. So we have 1 million kilograms, don't we?
Yes.
See how we're approaching million there.
Mm-hmm.
That's the key here. Now, the problem is, though, that our soil doesn't weigh exactly the same as water.
It's heavier
It's heavier.
usually.
And yeah.
Yeah. If we're using it for sporting turf, it's heavier.
Yeah. And we don't have to be super precise here, but we can sort of have a good estimate of the weight. And obviously, because we have a little bit of, thatchier stuff in the top there, I'm assuming, because often like pure sand can weigh about 1.6, so 1.6 times. But a good estimate is actually roughly about 1.5 times the weight of water. Wouldn't you agree with that? Is that a
Yes, that's a very good estimate
good
that works
multiplier?
quite well. So
Yeah.
if it's pure sand, you typically are going to multiply what water would be. So water would just be 1,
Yeah.
and pure sand might be from 1.56 up to 1.63. So you use what you want. And then once you mix in that little bit of organic material that we typically have in a turf grass root zone, now we're going to get down to something like 1.5 or sometimes even a little bit lower. So this is for sand-based root zones. If we're dealing with agricultural soils, we're going to be down around 1.2, 1.3. But for turf that's been top dressed with sand, or for turf that's growing in a sand root zone, we're typically going to use some numbers that are around 1.5, as you said.
Yeah. So we'll have to use that multiplier, and 1.5 times. We had million before. We agreed to that. We had 1 million kilograms. And now, no, sorry. 1 million. So we multiply 1 times. So that's 1.5 million. Now that means that 1 part per million of that entire soil that we have on this hectare, and we can imagine that's all our 18 greens plus 2 putting greens, 20 greens. We can guess that they weigh in total at the top 10 centimeters 1.5 million kilograms.
That's right.
So part per million of that
It's
will
so
be
easy.
1.5 kilograms.
Yeah, that's very simple, Bjarni.
That's very, very easy. So if we get a soil test that says, oh, you've got 10 ppm or 10 milligrams per kilogram of potassium in that soil sample you send in, then you can look at that. So each part per million or milligram per kilogram, it is 1.5 kilograms. So 10 would be 15 kilograms, right?
But
And
right, so that's if we're doing kilograms per hectare, right? So
yes, that's if you're doing kilograms per hectare, and then we would end up with 15 kilograms. If just to put that in perspective, how much is that? That is roughly if you have potassium sulfate, for example, that is roughly about 3 kilograms of potassium sulfate would have that, 15 kilograms of potassium in there. So often that's 1.5 bag of potassium sulfate. Put that into the sprayer. That's something that's, a lot of guys who are spraying potassium sulfate might know and feel, and, that makes sense to them.
Mm-hmm.
That is roughly in pounds. That is, what is 32 kilograms in pounds? Is that about 60, 70 pounds?
Mm-hmm.
70 pounds, something like that.
Mm-hmm.
So,
yeah, which is about, I think the fertilizer bags tend to be about 50 pounds.
Yeah.
So that's also a bag and a half, right?
Bag and a half. Yeah.
Mm-hmm.
So that makes sense. So that's if you're going to shift anything by add 10 ppm to your area. Now, for our Japanese guys and some other people who really love the grams per square meter. Now, the good thing is, again, this is a metric system, so things just shift by, you're just moving the dot between numbers, and moving from kilograms per hectare to grams per square meter. It means you just move the dot. We use the comma actually here in Iceland. You use dots in the US. And
Mm-hmm.
what about yourself? Are you dot or a comma guy when it comes to separating from zero?
I
do you
use
go 0.1 or do you say 0.1?
I use points, but
Okay.
yeah,
I do it too on my Excel sheet so I can keep them international. But my domestic Icelandic friends run into trouble because Excel doesn't understand what's going on.
Yeah, it's confusing when you for an American to see it for the first time, and people start putting commas in their numbers, and in America that's denoting thousands differences, but for some people that's the same as a decimal point. So it just depends where you are in the world.
Exactly. So you're moving the dot. So if you go on gram per square meter, you just move the dot by one. So if we had if 1 part per million means 1.5 kilograms per hectare, and it will mean 0.15 grams per square meter for if you move it to gram per square meter.
Okay, and so here's how I do it. I think of I will explain how I think of a square meter. Yep. So a square meter is 100 centimeters by 100 centimeters, or 1 meter by 1 meter. And I'm also thinking of the very convenient root zone depth of 10 centimeters, which is a 4-inch depth, which is quite reasonable for turf grass. So that conveniently has a volume of 100 liters, and that is because it's 100,000 cubic centimeters, because it's 100 times 100 times 10. So that if it was water, it would weigh 100 kilograms, or if it was water, it would weigh 220 pounds. But it's not water, it's soil. So we're going to multiply that by 1.5. So that's going to weigh 150 kilograms, or a little bit more than 300 pounds. And so the way that I think of this is if we take 1 gram, so I'm thinking gram per square meter. So I'm thinking about this slightly different than Bjarni is, but I think if you're watching this or listening to this and you're following us, I think it may be helpful to understand, to hear how Bjarni thinks about it and how I think about it, which is slightly different, but maybe you'll understand his and you won't understand mine, or vice versa, but we can learn. And I certainly learned from talking or listening to Bjarni explain it, because he is so native at this. So anyway, we've got my 1 square meter, and I know that it has a volume of 100 liters, and I know that the soil that occupies that 100 liters volume weighs about 150 kilograms. And I'm going to spread 1 gram of fertilizer across it, or 1 gram of potassium across it. And I'm going to assume that it gets distributed all through that root zone. And I know that 1 gram is 1,000 milligrams. So I've just put 1,000 milligrams divided by, or it's gone into 150 kilograms, and 1,000 divided by 150 happens to be 6.7, which I've memorized, or maybe it's 6.666 or 6,66666. uh, so that so I round it to 6.7 or 7. So I know that if I add 1 gram to 1 square meter, that's going to change the soil test amount by about 7 parts per million, or 7 milligrams per kilogram, because I've added 1,000 to 150. So that's how I tend to think of it. And then so we've been talking a little bit about fertilizer and additions, but we can also think of nutrient harvest. So the grass is taking up nutrients and harvesting from that hectare or from that square meter. And so the nutrient harvest, if you find that your soil test went down by a certain amount, you can know how much the grass harvested.
Mm-hmm. Yeah. And now you can figure that out on a bigger scale by by knowing the ppm, and if you have these tricks up your sleeve, the calculations.
Mm-hmm.
But
So yeah, I guess I'll just say one thing that I didn't, when I was a golf course superintendent, I didn't think quite like this because I was still learning, and even as I'm still learning today, that I think sometime during graduate school, I realized that the units were equal. They're just, um, they're, they're different units, but the amounts are equal. And what I'm trying to say is, the fertilizer that we apply can also be expressed as what it is in the soil once it's applied to the soil. And the nutrients that are in the soil, as they go into the plant, they also can be expressed in, it's all the same thing. And I don't know quite what the word is to explain that, but the numbers, as the nutrients from fertilizer go into the soil and as they leave the soil, what we're talking about, these conversions and understanding what a milligram per kilogram is, what a part per million is, and how these changes work, means that we can effortlessly switch from talking about fertilizer to soil concentration and vice versa, and nutrient
yeah,
harvest. And
yeah,
that's where I didn't do this when I was a golf course superintendent. I didn't know how to do it. And then it kind of occurred to me when I was in grad school that we could do this. So I just started doing the math and figured it out for myself, which of course is, I mean, and learn from other people who already knew this, because it ain't rocket science.
I know. What? Yeah, it's the same thing with me, because I didn't do it. It's only, I don't know, 10, 15 years when I started looking at it from that perspective. But before that, I absolutely did not look at it. I just looked at ppm and mg, and like, it's funny because it's very simple, but it also throws you off somehow when you're looking at this. So you don't actually dig into it. But once I'd sat down and spent maybe 3 minutes doing the calculations and realizing, it's like, okay, this is not that complicated. That, it's just, but mind you, I'm a metrics guy, and it's kind of easy from the metrics perspective. I've never done it from the imperial side. Have you done?
No, I haven't. I always like solve it metrically, and then if I have to express it,
Then you just do the
then I just like
conversion.
try to convert it to pounds per thousand or something. But
Yeah.
so why are we bothering to talk for such a long time about this? Why do we think this is important? Well, I think it's important to be efficient and make sure that we're applying enough fertilizer, or making sure the grass has enough,
Yeah.
and not overdoing it, but not underdoing it. Because I think if you're familiar with, like you could grossly over apply potassium, but if you're only, if you think that, let's say, okay, 10 pounds per thousand of elemental potassium per year would be a lot, right? Because that
Yeah.
would be 50 grams, so 500 kilograms per hectare, right?
Okay. Yeah. 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 50 grams. Yeah.
Right. So for Iceland, for England, for France, I think that's a lot. Uh,
It's sky high. Yeah.
that's sky high.
Mhm.
But if you're in Florida, that might seem reasonable because
Yeah.
it might be average in Florida. Because
Mhm.
I've heard people apply 20 or 30, like two
Mhm.
or three times that amount.
Yeah.
Um, and if you're only familiar with the fertilizer amount and you know that people in your area are applying, let's say 500 kilograms per hectare,
Mhm.
50 grams per square meter, or um,
10 pounds.
10 pounds per thousand square feet,
Yeah.
you you may not be thinking like, how inefficient is that? Well,
Yeah.
let's explain how inefficient that is. So how much is the grass going to grow? How much could the grass use?
Mhm.
So we've got let's solve this for Iceland and show how excessive that would be for Iceland, and then maybe we'll solve it for a warmer place. So
Yeah.
so there's various ways to solve this, but one way is to look at how much nitrogen you apply, and then just think of how much potassium could be harvested from the soil given the amount of nitrogen that the grass could potentially use.
Mhm. So for nitrogen, at the moment we're slightly higher this year than we used to. So we are slightly above 100 kilograms
Okay.
per hectare of nitrogen, which is about just over 2 pounds per thousand, maybe 2.1, 2.2 pounds per thousand,
And is that
or 10
fine
grams.
fine fescue, POA?
Well, we like to say fine fescue, but obviously quite a bit of POA coming in there as
Mhm.
well. But we just had a rough year. We lost a lot of grass, so we had to push them a little bit fertilizer wise. I would think it would be normal for me to be in the 60 to 70, 80K of nitrogen per hectare. That's point 0.7, point 0.8 pounds per thousand. That's sort of the normal thing. But if we use this year, because it's kind of handy, because we're at 100, we can say we're just about
It's
100. I think we're 106 at the moment.
so
So if it's
so
100K,
so if it's 100K,
yeah,
and we can expect that for cool season grass, for a lot
mhm,
of grasses, unless we're talking about seashore paspalum,
yeah,
but for all those cool season grasses, we can expect the leaves of healthy grass are going to contain about half as much potassium as they do nitrogen. So
yeah,
that means that if the grass used, we really don't even have to get into the soil here.
no,
We can just say if the grass used 100 kilograms of nitrogen per hectare, which would
hmm
be 2 pounds per thousand square feet, or
hmm
would be 10 grams per square meter. So if the grass used 100% of the nitrogen that you supplied,
you would
it would
expect half to be potassium.
you would
So
expect half to be
50K.
potassium. So
Yeah.
you need to make sure that the soil has that much. So
hmm
how much might that be? Well, we can instantly see how much we would need to have in the soil,
Yeah.
which would
We would
be
now we figure out yeah, we in the soil. What's your level at the moment for potassium? 30,
30. It's 37. So
37 parts per million. Yeah.
mhm.
You can convert that into kilograms per hectare by multiplying by 1.1, 1.5. Sorry.
Yeah,
See how easy it is in kilograms per hectare.
yeah.
It will be
So
2.15 for grams per square meter. But so that means in the soil you need to have 31 parts per million, or what's 1.5 times 37? That's about quick math here.
60.
60 something. Yeah, 60 kilograms per hectare in the soil of potassium. So if you were at that level, let's say that you get your soil test back and you're sitting there at 37 parts per million, um, then you were expecting your grass to use 100K of nitrogen. Then you would have to add the 50 kilograms
Hmm.
of potassium to your soil, right? And that would be work fine in Iceland. and you'll be pretty guaranteed you're not going to see a potassium deficiency.
And so you
And I've never seen it. So
so when you start thinking about these in quantities that are,
yeah,
we've got like three quantities we're looking at. We're looking
yeah,
at how much the grass uses,
hmm
which is really important. We need to make
yeah,
sure that's the most important. Okay.
yeah,
That's the most important. And then we're looking
hmm
at how much we need to apply as fertilizer, and
hmm
we're looking at how much is in the soil. The most important part is to make sure that we have enough for how much the grass uses. And it's really useful to be able to flip in whatever math you're using, whatever way you like to make these calculations, to
hmm
be able to flip between fertilizer rates, the amount the grass uses, and the amount that's in the soil.
yeah,
And Bjarni and I have done this so much that we kind of have mental tricks that we are comfortable with, and then
hmm
we solve these problems in our own ways. And
hmm
the way that I would solve this kind of problem is I just sort of bypass the soil entirely. And I'm just saying, is it reasonable to apply 10 pounds of potassium per 1,000 square feet in Iceland to turf that gets 2 pounds of nitrogen? And the
hmm
answer is no. Even if the soil test was zero, even if the soil
yeah,
didn't have any potassium in it, then I'd just say, well, just apply a little bit extra then. So we're
mm,
expecting the use to be half of nitrogen. We're expecting the use to be 50 kilograms of potassium per hectare, or 5
mhm,
grams of potassium per square meter, or 1 pound of potassium per 1,000 square feet. So if the soil was below the MLSN minimum, let's say the soil was zero potassium,
yeah,
I would
yeah,
just apply a little bit extra. So instead of
hmm
applying 1 pound, I might apply 1.5 instead of applying, I mean, yeah, maybe I'd just
yeah. I mean,
apply
if
two
I mean,
pounds.
to reach your, because I did the math for it right now, to
Mm-hmm.
reach the 37 parts per million, uh, and assuming our calculations are obviously they're not 100% accurate, but they're accurate enough,
Mm-hmm.
for what we're doing now. So we would need about 55 kilograms of potassium just to go from 0 to 37. So to be applying 37 parts per million. So in this case, if you were seeing 0 on your, which is unlikely, but if you find 0 in the soil, potassium, and you're going to grow grass in Iceland, and you would know that 100K would do you fine of nitrogen, then you would
Right.
just pretty much do 100K of potassium for that season. And given that everything stays in the soil, it doesn't get, we're assuming few things here, but then you should get your potassium levels up to very acceptable range that you shouldn't see any deficiencies. And then following years, you can stick to that 2-to-1 ratio. So you see how little that is that needs to be in the soil, really.
Yeah. So
50, the
so
1 pound per thousand of potassium in the soil is pretty cheap to buy in for.
But
It's not
that's
expensive, is it?
also an amount, like that MLSN minimum amount also can be,
Hmm.
if you express it in terms of what that is equivalent to in fertilizer, that's an
Yeah.
amount that we always want to keep in the soil that the grass
Yeah.
is not supposed to use. So
Hmm.
fertilizer recommendations made using MLSN are saying, let's keep your soil above a
Yeah.
certain minimum level,
Hmm.
and that minimum level is expressed in ppm.
Hmm.
And I don't go and say, well, that's equal to 55
No.
kilograms of potassium per hectare, or that's equal to this much. It's like
Yeah.
1.1 pounds per 1,000 square feet or something. But it's equivalent to that.
Yeah.
And if you're able to make these conversions, then you can express these in any type of number that you're comfortable with. So if we
Hmm.
if we take this now and go to some place that would have a much higher potassium requirement, I'll still
Hmm.
show that 10 pounds per thousand is a bit excessive,
Hmm.
I think. So basically, you'd have to go somewhere that you're applying 20 pounds of nitrogen per 1,000 square feet, or we get to numbers that are so big. I never use these numbers, so I don't have to calculate it in metric. But that would be, what's 20 pounds per
20
thousand,
pounds.
Bjorn?
Isn't that a ton?
That would be 1,000.
1,000. Yeah, or
That would be,
roughly. Yeah,
yeah. So that would be 100 grams of nitrogen per square meter, which
yes,
is
a lot.
a lot. And so if you use that
Yeah,
much, if you use
that's a lot. Yeah.
1,000 kilograms of nitrogen per hectare, I think. Do you know what the English Premier League puts on those ryegrass pitches? I mean, I assume it's more than
Well,
500.
saying that, I've actually heard applications of sort of up to 800, 900K of nitrogen.
Yeah, I don't know
Um,
firsthand
I
about
don't
that.
think, well, by no means is that everyone, so don't get me wrong, but I've heard numbers in that range for certain pitches. And I even heard them applying them at 1 to 2 ratio. So actually, 1.5, 1.6 tons of potassium per hectare, which
Well,
is a lot of potassium to be applied to
it's
a
a
football pitch.
it's a lot of potassium because it's about 3 times as much as the grass uses, and so then you start to
No,
wonder what's the
it's more.
benefit.
Well, yeah, yeah, yeah. If we assume that if we assume the 800 kilograms of nitrogen that was all used by the plant, I doubt that, to be fair,
No,
because these are very high sand content um, soils.
yeah. So
Um,
so in these kind of sports turf situations, you might start approaching that amount of nitrogen, but we're
mhm,
talking about like a really high amount of nitrogen
mhm.
for home lawns. You're putting 2 pounds, 3 pounds, 4 pounds, and even in Florida on sandy root zones for high quality turf these days. I know the recommendations and the practice, what people were doing, maybe 20 years ago or so was a bit higher, maybe approaching 20, but I think
Yeah.
now it's more common for people to be in the 5 to 10 pound range or something that would be like 250 kilograms
Yeah.
up to 500, and it's
Yeah.
almost a year-round growing season.
Hmm.
And so we're talking nitrogen numbers here,
Yeah.
and these type of nitrogen numbers, you're going to have half as much potassium being used, and
Hmm.
so there's no way that you ever get up to needing 500 kilograms of potassium per hectare unless you apply nitrogen at 1,000. So it's
Yeah. That's.
I just I find it's quite useful to
Mhm.
be able to be familiar with how much the grass is using. And I
Yeah.
and I think people tend not to think of how much the grass is using. They just think of how much they put as fertilizer. That's how I used to do it. And
Mhm.
I used to just be throwing down as much fertilizer as I could, just thinking more was better
Mhm.
and not thinking at all about how much the soil could hold, how much the
Yeah.
grass could use. And when you start thinking about how much the soil can hold, what's a reasonable amount of this element to have in the soil? You can
Mhm.
you can look, for example, at the Global Soil Survey results, which I know Bjarni, you took part in that
Mhm.
back in 2014 or 2015, and those uh, Global Soil Survey results show what is normal for high quality, mostly golf course turf
Yeah.
around the world from a pretty broad set of sites. I'll put a direct link to that article and that data set in the show notes.
Mhm.
Um, so you can check that out. But you can see once you check what's normal in the soil, and that's often expressed in units of parts per million or milligrams per kilogram, when you see what's normal, you can then convert that to what is that as fertilizer if you're particularly interested in that. And then
Yeah.
when you make your fertilizer applications, you can also think, well, if the soil, for example, has this much magnesium, why would I try to quadruple that? Why would I be applying fertilizer that would quadruple that and be like 20 times what the grass could use? It doesn't make any sense. So
Mhm.
I find it's useful to think in terms of quantities that always go back to the grass. First, go back to the grass, how much the grass will use, and then also sometimes look at how much the soil normally would have, how much the soil could hold.
It's also, I mean, because I think back in the days people didn't even look at these basic steps very well because many um, soil, fertilizer recommendations were often recommending keeping potassium levels so high in the soil. Wasn't the recommendation somewhere above 100 parts per million? Well, quite
Some,
high.
some of
I mean,
some.
I'm talking older. I'm talking older recommendations from quite a few years ago. But if you look at a lot of putting greens that are grown on very low CEC soils, sands, effectively, actually play quite well. Grass is doing fine, right? But you physically couldn't fit all of that fertilizer recommendation. It wouldn't. There's not enough cation exchange capacity within the soil to be able to deal with it. So it's no wonder people are seeing year after year of applying potassium at high rates, seeing, you're not reaching your goal, so this can't reach the goal. So, but that's obviously happening on very low CEC soils. But so that's why, yeah, and that's why I think it's smart to look at what's the grass actually going to be using, and then is there a limit we can't go below and just work from there. Just
Yeah.
makes more sense to me. But
Yeah, if you're watching this or listening to this, you're probably thinking along those lines already.
yeah,
And I know there's some people that just think completely the opposite of what Bjarni just said, and they think the opposite of the way that I think about it. So they think the very fact that you're growing in sand that doesn't hold very many nutrients and it's very low in nutrients. So they'll think that for that reason, they should be like constantly applying so many things. And those aren't the people that come to my seminars or pay attention to this.
no,
But you and I know
yeah,
from observation, I was one of those people too 20 years ago, or
yeah, yeah.
25 years ago when I was a superintendent. I put twice as much potassium as nitrogen. And I was convinced that I was making the grass healthier by doing that. And I
Mm-hmm.
put a lot of other stuff. I mean, mostly it was potassium, but I mean, like if I could throw some phosphorus in there, I did. It's like if I put calcium nitrate or something, I was happy. I was
That's
thinking that was beneficial.
Loved that, but you gotta remember there's a bunch of seashells in my sands anyway, because it often comes from the ocean, the sand we're using. So I had my ppm numbers. You were talking about calcium being
Hmm.
in the 10,000s. I've seen those numbers.
Yeah.
So adding calcium to that makes limited sense, some would argue these days.
Yeah. So, but back in the day when,
Hmm.
before I thought about this like I do now, I was just kind of thinking apply a lot of stuff. But
Hmm.
then I've been observing grass around the world and observing the way that people maintain it. And I've had to reduce my nitrogen numbers that I think are normal. Um, which you've seen me write about on my blog a little bit, where I used to think that if we link it to growth potential and say something like uh, 30 kilograms of nitrogen per hectare would be the maximum that you'd use with just like perfect growth potential, like much warmer than you ever could reach in Iceland. And I realized when you run that number, it's too much. It makes grass grow too much. So I dropped that down to 20 now,
Hmm.
and it works much better. So that's just with nitrogen, but with the other elements too, as I started doing more soil testing, and my PhD was about potassium and calcium and magnesium availability in sand root zones. So I did a lot of soil testing um, in my university studies, and I realized there's a lot of turf grass that's growing really well, and it's a very high quality turf grass in soils that have nutrient levels that are much, much lower than what the recommendations were. And so then, you get that in your mind, but you still don't quite believe it. And then you see it some more, and then you see it some more, and then you do some more experiments, and then you realize, yeah, I'm really comfortable. Even with MLSN, when MLSN first came out with Larry Stoll from Pace Turf, Wendy Galernter from Pace Turf, and myself, we developed MLSN and introduced that in 2012. Those numbers were lower than what I was recommending at the time. I
Hmm.
was recommending 50 parts per million potassium, and MLSN was 37. That's significantly lower. I was recommending 75 parts per million magnesium, and MLSN dropped it down to 47. So I was like, ugh, these are a little bit low. It seemed a little bit low to me. And now I just think, oh yeah, MLSN more than enough. Don't worry. You don't even have to think about it. Of course it's fine.
I think I recall, I could be wrong here, but I think I recall something with you and Larry, probably on the Paster of YouTube. Is that possible back in the day? This is,
Mhm.
I'm assuming,
There's
2012
yeah.
era. And it's very evident by Larry that he's very sort of reluctant. You can sort of read between the lines. He finds these numbers to be very low at the time.
They certainly
Is that, am I remembering things
that's
correctly?
yeah,
Or,
and I think I'll look for that video. We recorded a few back in
yeah.
the 2011 2012 time, and definitely when MLSN was introduced,
Mhm.
uh, the Larry presented it as an alternative set of soil nutrient guidelines if you really wanted to approach managing nutrients in the most sustainable way possible. But it's
I see
like,
why you dropped it to MLSN. That's better.
right. So it's
Oh,
like he still kept so it's like, here's the conventional guidelines.
mhm.
MLSN is an alternative to those. But
Right.
now we just kind of like we've realized that MLSN is actually fine. We don't need the conventional guidelines anymore.
Yeah. No.
And you can do just fine with MLSN, and you can do fine with a little bit less than MLSN if you really want to push things.
We've done that on a number of greens where we've gone really, really low. I haven't and didn't see problems. So
But
yeah, that's why I'm pretty comfortable with it as well. I mean, it's mostly on uh, phosphorus. I've had greens running down to 10, 9, no issues, 10 parts per million. So, but that's why I was deliberately taking it down. I'm just trying to see how far I could go for fun. And like I said, we didn't get that purpling at that levels at that soil. So I'm not saying that's going to be like that everywhere in the world, but you can try. I mean, the worst thing that happens in the beginning, it just gets a little purpley, and then it's kind of cheap to add phosphorus to your tank and just spray it out and rectify the problem. So if you want to live on the edge, that is, if you care not for the edge,
yeah, but
stay at the MLSN level, you should be fine.
yeah, I just
Or above.
yeah, I think once you find out how
Hmm.
to flip between uh, these units. So flipping
Yeah.
between, basically we're talking about fertilizer amounts versus soil concentration amounts. And what
Yeah.
I'm trying to say is they're equivalent. So
Hmm.
kilograms per hectare can also be expressed as milligrams per kilogram once you account for the mass of the soil.
Yeah.
And that's something that I don't know that listening to a podcast or watching a video is perhaps the best way to learn it. So I'll be interested for feedback.
Mhm.
I suppose some
I
people
think
are going to listen.
if I can recommend, if you're
Mhm.
listening to this and you're a bit scratching your head, the cheat sheet you talked about is actually really, really good. Because hopefully you've picked up bits and bobs here to make that more easy, and then open a spreadsheet and do a little bit of calculation yourself. And I think that's a good way to get into it, and you should be able to get that done in, set aside 30 minutes. You'll
Yeah,
get this for the rest of your life.
I think yeah, a little bit of trial and error.
Yeah.
I certainly did some trial and error with this.
Hmm.
And then yeah, eventually you sort of get it, I guess.
Hmm.
But it is it's not just about doing as little as possible and trying to get below MLSN. It's also about making sure you don't have any deficiencies. And
Yeah.
so I always look at this as like, how can I figure out precisely how to apply just the right amount and make sure that I'm like in 100% control of how much nutrients the grass is getting supplied with. And you
Mhm.
see like it's interesting to see how people, certainly in the United States and Canada, they seem to really push green speed.
Yeah.
And at a lot of top clubs, they need to have green speeds that are really high. And to do that, you need to have really low growth. And you certainly don't want to mess around with any nutrient deficiencies in that case, but you don't want to be over applying anything either. So
Mm-hmm.
it sort of makes sense to be really familiar with the nutrient supply, because nutrient supply is going to have a huge effect on how much the grass can grow. And
Mm-hmm.
and when you're pushing to have green speeds that are 12 feet or something, and the weather's not so good, then you want to make sure that it has enough potassium. And you know, so much of the so much of the research, like about anthracnose disease and stuff, right?
Mm-hmm.
So you've heard about the anthracnose and potassium and stuff, and it's like, if you use MLSN and you make sure that the grass is supplied with enough potassium so that it won't drop below the MLSN minimum, I'm sure that you're not going to have an anthracnose problem. But the way that the experiments tend to get designed is like, this is a no potassium treatment. This is a 2 pounds per thousand treatment. This is a 6 pounds per thousand treatment or something. And what
Mm-hmm.
you find is any potassium treatment, any potassium application provided pretty much the whole effect of
Yeah.
reducing the anthracnose disease. And then if you look at that and say, well, if you would look at your starting soil test amount, look at how much nitrogen you're applying, and then you figure out how much potassium you need to apply to keep above the MLSN guideline, you would have been applying a substantial amount of potassium.
Mm-hmm.
And so then you probably would have gotten the effect of reducing the anthracnose. So I think this is definitely a different way of thinking about things, because I see, like, the way research gets done, it tends to be fixed rates. It's not really as site specific as what this MLSN and clipping volume and growth ratio and a lot of the stuff that's getting used with great success by turfgrass managers now. But maybe it's a little
Mm-hmm.
bit ahead of the research, I'd like to think. And we're not just like Pied Piper steering everyone down the road to ruin. I hope not.
I mean, I think there's a lot of people who have taken this up. I've never heard any horror stories from anyone saying, oh, I started doing this. I was measuring 40 parts per million in my soil of potassium, and my POA greens were hammered in anthracnose. I haven't really, I don't know. Well, you might speak to more people about this, but I don't seem to be seeing that. And in my environment, like I said, I mean, we have a bit of a strange climate, a summer climate, anyways. But in these cooler summers, we're not seeing any problems with it so far, at least. And like I say, I've actually deliberately gone below these numbers for fun, because I'm like that. I just live on the turf edge.
Yeah.
but and again, I'm not recommending people to do that, but I've just been doing it because I wanted to know what happens. And like I said, we've just haven't seen it. Saying that anthracnose is not a massive problem here. We see it on obviously, if you're on POA greens, you can see it, but it's not a massive problem in our climate. But
And
obviously, can happen.
so you're recommending, I'm just imagining if people want to figure this out, so one
Mhm.
resource you're suggesting is the MLSN cheat sheet, which I'm going to put a
Yeah.
direct link to.
Hmm.
And what are some, you said open up a spreadsheet and start trying to solve the
Well, you
problem.
just put the numbers in and just try to, what is it? Does it make sense to you? Does it make sense to what you're applying or have been applying, for example? It's like, it's always good to just see these numbers. What would you have thought would happen to a soil if you applied, you know, um, 2 pounds per thousand of potassium? Are you seeing your soil samples? Given you're consistent on your soil sampling, what's happening in the soil? Have you seen it? Is it going up, or is it, what's going on in your soil? Um,
I,
and
I'll look on Pace Turf also. I think there should be some good explanations on Pace Turf also
Mhm.
about converting between parts per million and mass, like fertilizer mass units that might
Yeah.
be in American units, like pounds per thousand
Yeah.
square feet or something. So,
Hmm.
uh,
I have to admit, I haven't attempted this in the imperial world because it scares me a little bit all the time because because the numbers change. The beauty about the metrics, the numbers don't really change. It's the prefixes to, and all the that might change, but not necessarily the numbers. So that's why I get scared.
all right. Well, I think that's enough about parts per million, Bjarni, and let's see what kind of feedback there is. If people have a lot of questions,
Yeah.
um, I
Maybe
think
we did a good job, or maybe we just bamboozled everyone and they don't have
yeah.
any idea
So
what we're talking about.
maybe let's see. It's hard for me to assess,
Yeah.
but we'll get some feedback of like that was the worst episode ever, or it's like
Yeah.
that was really enlightening, or it could be. And I guess I guess some people are going to say that's kind of interesting. I understand some of it, but I have some questions. So if
Yeah.
you
Yeah.
do have some questions, send them
And,
to me.
and
Everybody knows how to get in touch with me, and we
and I fully understand because I personally, when it comes to numbers, I prefer seeing stuff, and I'm good at maths with just with my eyes, but when I have to do stuff like chatting to you here, making sure my volume is okay, and then talking numbers can sometimes just go out of the window.
yeah.
And
Well,
I can imagine sitting on a fairway mower listening to a podcast, listening to numbers.
uh huh.
It can be difficult to some of us. We don't all think the same. We use our brain power in different ways.
That's right. So it if you feel like you want to do this but you can't quite get it yet,
Mhm.
um, and you really want to learn and you think like, yeah, this is important. I agree with what they're saying, but I just don't get
Yep.
it.
Mhm.
That's fine because we didn't know this. we
Yeah.
we didn't know this, and we learned it.
Yeah. We were managing golf courses and we didn't know this. So
Right. I was getting a PhD and I didn't know
uh,
any of this, right? So and we will be happy to try some alternative ways of explaining this. So I can do a
yeah.
blog post or Bjarni and I can do a tutorial, or we can get our collaborator Jason Haynes, who
Yep.
is not here today due to being quite busy with
Mhm.
work, but he would probably have some good insight of also other ways to think about this or to learn it. So I'm hoping that more people around the world can be very familiar with these numbers. And I know a lot of you are probably like, yeah, we know that, we know that, we know that. So that's perfect.
Yeah.
Um, but yeah, it's certainly something that I kind of look at my career from the time before I knew how to do this and the time after. And the time
Hmm.
after, I feel much more in control of
Yeah.
what I was doing. Um, so
Yeah. Just people I've helped out with this is exactly the same. Is that they felt they have way more. This makes more sense. It's actually easier once you get over the sort of getting comfortable with it. It just gets way easier, and but it's one of those things that you need to learn a little bit, and once you're above the hump, it actually feels like you're going down the hill,
yeah,
which in a positive way.
and they never
Not like
teach
our life is going down the hill, but
and they never teach us this in school. That this is not
no,
the way we get taught in school.
no,
It's not the way we get taught by when we're doing an apprenticeship or in America we do an internship and or just work on the crew, and we learn a lot of things, but we never learn what Bjarni and I've just tried to talk about. But when you're making decisions about fertilizer or when you're applying fertilizer, um, it's quite useful to be able to do this.
yeah,
So
very,
I think I should ask you about frost delays while I have the chance. Have you
hmm.
had frost yet?
We had frost, yeah, 2 nights, uh, and I was a bit nervous about the first one because we had been averaging in the 10, 12, and then the coolest was like 9 degrees, and then all of a sudden we went to -2 degrees over about a 5 hour period,
Hmm.
and got quite frosty. Um, so, but at about we had the first tea times out at 8, but the sun was up at 6, I think, around about 6 o'clock, and at that 7 o'clock time, it was actually quite soft, the surfaces, so I wasn't too concerned about it. I turned on irrigation. It was the sort of sweet spot where you can actually use the irrigation. Sometimes you can, sometimes you can't, but it was the conditions were favorable, so we could actually hit the frost off most of the areas. But still, we sent out play at 8 o'clock uh, on the back nine instead of the front nine, and fairways that were frosted. We didn't have any irrigation to or anything, nothing. I deliberately walked onto certain greens,
Thank you.
nothing, no problems. So we saw no issues with that frost. Um, and again, I mean, this is, I think very strongly about this. We need to research this field way more, because I think a lot of people, and most of the courses around me closed uh, for longer than we did. Certainly, that is because we often let people go out on the 1st and the 10th at this time of the year, but just get more people through. Most people just want to play 9 rounds. It's late in the season. Um, so we didn't do it on the front nine right away. We did it on the back nine right away. And like I say, no damage during these conditions. I understand. I know there are people who are listening to me. Wow, I've seen footprinting and all that. I get that. And that happens. That definitely does happen. We know it for a fact. We've seen millions of pictures of it. The question is, and what I have a big question mark is when does it happen? Because it clearly doesn't always happen. It clearly did not happen here. And this is a environment that I thought would be conducive to this, where the grass hasn't been in a colder environment, where when grass starts getting to the end of the year, it starts hardening before the winter periods. But it usually happens once your average temperatures drop below about 6 degrees, so 4 degrees. It starts getting hardier and handle the winter a little bit better. So I always thought that, like, if it hasn't had that time to do that, which is exactly what happened for us now, and then you get frost, is that the grass more fragile and thus can lead to footprinting and these black spots or not? In this case, no. But if we would have hit -4 degrees, would have been different. If the humidity levels would have been different, wouldn't that made the difference? I think so, but I don't know where that, I'm assuming you don't know either. Where does that, when can we predict the footprinting damages to occur?
And and the footprinting damage. So I talk with people in Japan about this because they don't do frost delays in Japan.
Yeah.
And what's customary in Japan is to put a small cover, a frost
Yeah.
cover. They typically will change the hole location in the afternoon of the previous day, because in Japan, people just play in the morning to early afternoon and then they go home. So it's very rare. I mean, basically, there's nobody on the course after 3, 4 p.m. And so,
Dear Lord, I would like to experience that.
yes, it's lovely. Come to Japan. Come to the 2025 International Turfgrass Society, the International Turfgrass Research Conference in Karuizawa, Japan, from July 12 to 16, 2025.
I need to do
And
that.
and that is going to be a superb conference, and you can have a chance to see how Japanese golf courses. So they'll go off 1 and 10 tee every morning.
Yeah.
But the last tee times are at like 1, so or 1:30, and so
Yeah.
holes 1 and 10 start to be free at 2 p.m. and then half of the course is free by 3, so you can go out, you change the hole locations. So in the wintertime, you can do that. You change the hole locations, and then you cover with a small sheet that only covers a portion of the green. And these are all creeping bentgrass greens that I'm talking about. And so the next morning, the maintenance staff will go remove the sheets, and it would be common to have 60 days of frost. Pretty much like all of January and February would be frosty. And in some places, it would be an even longer frost season. And so you've got the maintenance staff walking across the uncovered part of the green that has frost on it and removing the sheets. So that's leaving footprints. And then the golfers come and play, and they're also going across the greens and and walking on frosted turf. And so I asked people, what's your do you do all the holes? Do you just do the first few holes on each nine? How does it work? What type of damage do you see? And a lot of people say, yeah, we'll see footprints when the first frost come. They'll see footprints. It lasts for about a week. It's no permanent damage, and after that, there's really nothing. And then they just play golf on that, and so that can be a lot of money if it's a place where people actually want to play golf and they're willing to pay money to play golf. Then that can be a big business decision. And it just baffles me for public facilities to turn money away when I'm pretty sure that they're not going to see any kind of permanent damage. But
I would, what I strongly recommend is that golf clubs that are in this frost delay area around the world, if they could just join forces, and each golf club will pay $100 to a research fund that will aim at finding a prediction model, frost damage prediction model. And then we could predict, okay, well, actually, we're actually highly likely to have damage. Mind you, if you could do the Japanese way and just accept the damage and don't think it is a real problem. But if you are really, if you really don't want to have any footprinting or whatever on your frosted turf, can you imagine? We surely get that amount of money, spend 5-6 years researching it. Surely we can come up with a prediction model that is, correct 90% of the time, because that would save a lot of money for the golf industry.
Yeah, I'm surprised at how pervasive the frost delay is. But then you go to Japan and Korea, and they have absolutely zero delay.
Yeah.
And then like that just hits home to me. I'm going to Japan tomorrow, and visiting some golf courses, and of course that's going to be a topic that comes up just because I'm so curious about it, and I'm trying to learn. But Bjarni's right. It's a ripe area for research. So whether
it's actually one of those things you would research it to save a bunch of money, because that's the whole purpose of it, right? To not throw away business for no good reason, because that could have further damage down the road, denying people services when they could easily get around and not cause any issues. But I need to understand this Japanese thing of not playing in the afternoon, because we were not there. we have a lot of rounds in the afternoon. Just this July, we had 9,360 some rounds out of the ones we actually managed to register, because
which month?
Midnight don't actually register.
Which month?
July this year.
July, you had 9,360
registered rounds. So these are confirmed rounds. People actually played.
Is that on 27 holes?
No, just 18 holes. This is just off the first tee. Yeah, no. We had 7,700 rounds on the 9-hole course that we have. So we catered to 16,000 some people in July. And these are confirmed rounds. Mind you, people can show up at midnight or 2 o'clock or 3 o'clock in the night and play. And there are a certain amount of rounds. In the entire month, I don't know, 300 more rounds, 400 more rounds, something like that. But that averages on the 18 hole like 302 rounds per every single day on average. And we don't do good weather. Remember that. Saying that, no, in July, we never crossed 20 degrees Celsius. So we never reached the 70s in Fahrenheit.
Yeah.
So that's the numbers.
And
MLSN works on that. So
you've got harsh winters, and you've got heavy play during the summers. Yeah. So I consider the Iceland climate to be quite challenging for growing grass and quite stressful for grass. So if MLSN works there, that gives me some assurance that it's pretty solid for turf that's under cold stress or under traffic stress.
Yes, I think traffic stress we've proven.
Well, good. Yeah, we should have a big international turfgrass conference in Iceland someday,
We need to do that.
right?
We need to do that.
Because I know you organize the Icelandic Greenkeepers Association does have some annual conference and
Yep.
sometime you should like invite the world and
Mhm.
of course not everybody can come, but I'm sure that some people would be quite interested to go learn more about the very
We
interesting
actually are
conditions there.
having one we're having our 30th birthday, our Icelandic Greens and Groundskeeper Association, our 30th birthday next year. So we're having a conference on the 7th and 8th of March
7th and
this
8th
year.
of March. Okay. So
And we already have lined up speakers, which are interesting speakers.
I've heard of one of those speakers, I believe, and I don't
Yes.
know who the others are, but I don't know
Yeah.
if you want to disclose that. But is this open to the public at this point?
Yeah, we when we have our conference, we don't actually charge anything in because we need to get as many. We just want to get the the knowledge out there and people to come here. And obviously, mostly it's just greenkeepers show up, but we have one. There may be 70 people showing up for this event.
But if somebody wanted to come from India, for
Yes,
example,
they could come.
they could come. Okay.
Yes, they can just contact us, and then I'll probably once we've nailed we have them very good speakers this year. We have about 5 foreign speakers coming in, so don't worry. It's not as if you're coming in and everyone's chatting Icelandic on stage. It's going to be mostly English, so don't worry about that.
And I'm not one of them, so you don't.
You're actually not one of them,
right? So
I'm
you
sorry.
don't have to worry. You don't have to worry that you'd have to hear from Micah again, and you're like, well, we've already heard all of his stuff. So these are going to be something that would be more interesting than that. So
yeah, I'll probably later once I have everything. We actually just had a meeting this morning. Finally, we're about to pinpoint everything, but then I'll let you know exactly the speakers. But there are good speakers coming in.
Wonderful. Well, let's. I would encourage people to do that. I encourage people to come to Japan and learn about golf course management in Japan also, or just watch my YouTube channel and listen to the ATC Double Cut, and you can hear and see some of the interesting things as I share as much as I can about the very interesting things that I get to learn about turfgrass management around the world. All right, Bjarni, we managed to do 1 hour and 23 minutes already on the very exciting turf math topic of parts per million or milligrams per kilogram. Thank you so much for joining me.
Thank you. You're having fun, man.
Yeah.
Time flies.
And thanks everybody for joining us for this. Bjarni, do you have anything else you want to share before I click the stop recording button?
No, I think just thanks for having me, Micah, once more, and I'll look forward to the next mathematical problem we'll solve here.
Yeah, and again, go ahead and let us know if you need a little bit more guidance on this or want some more advice about trying to make sense of what we're talking about. For now, we will go ahead and not take up any more of your time, and I will sign off. Thanks, Bjarni, for joining me, and I will say bye-bye for ATC from Bangkok. I am Micah Woods. Bye-bye.